everyone, myself Anagha and today I'm going to explain you all about photoelectric effect. H. Hertz in 1887 made an interesting experiment where he found out that when a light ray strikes the neutral metal, it emits electrons, which were later came to be known as photoelectrons. Metals like cesium, potassium, rubidium, etc. were found to have high photoelectric effect. He set up an experiment which states that there is a vacuum chamber given here and electrons are ejected within this vacuum chamber. There are two metal electrodes which are connected to the battery and we also have an ammeter present here. Now, when light ray strikes the metal surface which is negatively charged, then photoelectrons are ejected from the surface of the metal. From this, he made up following observation. The first observation is there is no time lag between the striking of the light and the ejection of photoelectrons. As soon as the light ray strikes the metal surface, photoelectrons are ejected from the surface of the metal. Thus, this can be concluded to be an instantaneous process. Threshold frequency. Threshold frequency is known as the minimum frequency with which photoelectrons are ejected from the surface of a metal. Below this frequency, if a light strikes the metal surface, then photoelectric effect is not at all possible. Next, number of photoelectrons. Number of photoelectrons mainly depend upon the intensity of the incident radiation. Higher the intensity or brightness of the incident radiation, then greater is the number of photoelectrons emitted from the surface of a metal. This graph shows us number of photoelectrons ejected is independent of frequency, but it is dependent upon intensity. Hence, we have high intensity light and low intensity light. Next, kinetic energy of photoelectrons. Kinetic energy of photoelectrons mainly depend upon the frequency of incident radiation, but they are independent of intensity of incident radiation. For example, red light. Red light has the maximum intensity, but it has minimum frequency. So therefore, kinetic energy of it is not dependent upon intensity and hence photoelectric effect is not at all possible when it strikes the metal surface of potassium. But yellow light has the greatest frequency and hence photoelectric effect is possible when yellow light strikes the potassium metal. And thus we can conclude that the threshold frequency of potassium metal is greater than the threshold frequency of red light, but it is less than the threshold frequency of yellow light. Now let us see what Einstein told about photoelectric effect. Einstein in 1905 explained what is actually the photoelectric effect. Photoelectric effect is nothing but when a ray of light is incident on the surface of a metal. The metal should be neutral. Hence, the electrons get rejected from the surface of the metal and the metal becomes positively charged. So when a light ray of sufficient frequency is incident upon the surface of a metal, then electrons are ejected from the surface of this metal. These electrons which are ejected are called as photoelectrons. He explained this on the basis of Planck's quantum theory of electromagnetic radiation. And hence, this light which is incident on the surface of a metal must have the sufficient frequency, and that minimum frequency with which the photoelectrons are ejected is called as threshold frequency. Higher the energy of the incident photon, then higher amount of energy is transferred to the electrons, and these electrons gets ejected from the surface of the metal very fastly. And hence Einstein gave us a formula that is nothing but energy of photon is equal to work function plus maximum kinetic energy. This formula was mainly based upon Planck's quantum theory. What is energy of photon? The energy with which the photon is incident on the surface of a metal. Energy of the photon has a formula E is equal to h mu, where your h is nothing but Planck's constant. Planck gave this constant and the value of the Planck constant is 6.626 into 10 to the power of minus 34. This is called as Planck's constant and your mu is nothing but frequency. This mu can also be interpreted as F is equal to c by lambda, where your c is nothing but speed of light in air or vacuum, that is nothing but 3 into 10 to the power of 8 meters per second, and lambda is the wavelength with which the light is incident on the surface of a metal. This is the energy of a photon which strikes the surface of a metal. What's work function? Work function is also called as binding energy or threshold energy. It's represented by nothing but phi naught. What is this binding energy? Binding energy is the minimum energy with which a light ray has to strike the metal surface. Below this minimum energy, photoelectric effect is not at all visible. So binding energy is the minimum energy with which a light has to strike the metal surface. And next is the maximum kinetic energy. Maximum kinetic energy can also be represented as Ke max is nothing but half mv max square, where m is the mass of the photon and v is nothing but velocity. Kinetic energy can also be represented by ev naught, where v naught will be your stopping potential. So hence, what is Einstein's equation is nothing but h mu is equal to h mu naught plus kinetic energy, where mu naught will be your threshold frequency. To this, Einstein got Nobel Prize for Physics for explaining this photoelectric effect. Thus, photoelectric effect can be simply said in a line. When a metal with a sufficient frequency strikes a metal surface, electrons are ejected from the surface of a metal. These electrons which are ejected from the surface of a metal are called as photoelectrons. The number of photoelectrons ejected from a surface of a metal are mainly dependent upon the intensity of the incident radiation, and the kinetic energy or the stopping potential are mainly dependent upon the frequency of the incident radiation. Thank you.